Hi, this is Vaisal. Reasoning models are powerful, for sure, but expensive. And I wanted to prove that we could teach a small 1 billion parameter model to reason on the edge. This is my Tunix Hackathon submission. And the results are basically, for example, in math, the model now outputs distinct reasoning tags, as well as in creative writings, where it plans its narrative structure before writing the final answer. So here's how we built it. Of course, we started with a massive problem, the dataset imbalance. Our original data was 30% science questions, which was the dominant domain, whereas in the coding was only 2%. To fix this, we implemented disco sampling by applying a temperature of 0.5 to the sampling probability. We flatten the distribution curve. This simple trick, it triples the coding representation and prevents the dominant domain, in this case the science, to overpower the gradients. As for the reward function, which is the core of our training in the GRPO reward function, which uses a dual path strategy. First, every response must pass a hard formatting gate. Then the path splits. For verifiable domain, like math, we check against ground truth. However, for the creative domains where there is no ground truth, we use fast heuristics. We calculate a composite score based on length, lexical diversity to prevent repetitive loops, and prompt relevance. And of course, we chose heuristics over an LLM-as-a-judge to reduce latency. And as a result, this allowed us to train on thousands more data samples within the 9-hour of Kaggle session limitation, prioritizing the volume of experience over precision of check-in. And this is my final fine-tuning pipeline architecture. And for developers who would like to use Tunix to fine-tune models, Tunix makes this RL training surprisingly simple. You don't need to write complex loops from scratch. Simply define a GRPO configuration class, where we set the number of generation to 4 and the beta to 0.04 to prevent the policy from diverging too far from the base model we chose, which was the Gamma 3 1 billion parameter. And at the end, by combining balanced sampling with efficient heuristic rewards, we proved that deep reasoning isn't just for massive models. It's accessible, efficient, and ready to be used on small devices.